Today we are going to start looking at bivariate data, and in particular we're going to be looking at scatter plots and best fit lines that we can create and get from them. So the first thing here that we want to understand is that bivariate data, that prefix of bi means that we have these two columns. So we have sort of two things being compared. So in this situation, it's talking about how Gwen collected info from peers at her school on how much water they drink and then the amount of miles that the student could run. And she got this following list of data. So the first student drinks 12 cups of water a day and they can run 3.5 miles. Okay, the next student drinks 2 cups of water a day and they can run 1 mile. We can then turn that info into a scatter plot. So this is something you should have done in previous years. Okay, so when we look at this, right, we should recognize that this can be an ordered pair of 12, 3.5. So then if we go over here to our graph, we can find 12, 3.5, and we can find that point, right? So all of these points are plotted over here. So I already have this created for you. So if we just take a look at this, if we were to create this on our own, is there anything that we think we might have done differently? So this is sort of a personal opinion. It isn't like there's one right or wrong answer. But for example, one thing that I might have considered if I were going to do this is I might have counted this scale factor different for my cups of water. Because if I want to identify where 12 cups is at, well, that's maybe a little bit tough for me to find because this is only counting by 2.5s, right? We know this is 2.5, we know this is 5. So maybe I would have gone across here and counted 2, 4, 6, 8, 10, 12. Okay, so maybe I would count my x-axis differently. Maybe you would prefer if that y-axis was actually counting by 0.5s. Okay, maybe you would have preferred something different. There isn't a right or wrong answer, but just things that we can do. Our whole entire goal of when we're making a scatter plot is making it easy to read and easy to get information from. So how we label and sort of how we have that information is really important. When we look at this data then, is there anything that we notice about that data? Is there anything that we just sort of jumps out at us as we look at all that data plotted that we might not have seen if we just saw these random numbers? So one of the things that might jump out to you as well, it's not a perfect line by any means, right? We do have some other points going on. We do sort of have this general idea of all this data going up in this area sort of in between these lines. Now, we have what we call a couple outliers. So for example, we have this point sitting up here that's just sort of randomly in a different place, right? We call those outliers, points that happen maybe slightly different or drastically different than the other points that are going on. One thing that we can do is try and summarize all of this data into a mathematical equation. So just like we've been talking about linear functions and writing lines, we can do that even when something isn't a perfect line. And there are very fancy, complicated ways that we can get the best option, but for right now, we're just gonna sort of eyeball it. Okay, we wanna look at this data and we're gonna see if we can't find something that does a good job of representing that exact statement that we said. That all of this sort of has this idea of this, this upward positive trend. We want to see if we can't mathematically represent that in an equation. And the way that we're going to do that is we're sort of going to look and see if we can find 2 points that do a generally good idea of representing the info that we see here. So for example, we would say that this point and this point are not good points because if I draw a line between those 2 points, it goes way above all the other points, right? And I wouldn't want to pick this point and this point because that just makes a horizontal line. But where can we find 2 good points that sort of generally give the overall trend? And if we kind of look, I kind of see this idea going on with this point, this point, this point, this point, and this point, right? Sort of going up here where we have some above and we have some below. So maybe we would pick this point here and this point here. Now, this is where labeling this a little bit better could have been more beneficial, because now if I go, okay, well, what point was that? Well, okay, 5, 7. It's just past 7.5, so that must be my 8,3, right? That's a little bit annoying. If we would have labeled it better, that would have been easier. Okay, and this is my farthest one over here, so this must be my 13,4.5, because that's my largest. Okay, so 2 points that I think do a good job of representing this data. If I were to draw a line in between 8,3 and 13,4.5, right? And if I draw that actual line in there, I'm going to use the edge of a sheet of paper here to help me get it a little bit better so I'm not too messy. Right, we can sort of see that that line I just drew in there is sort of that central trend where we have a few points above, a few points below. We have these couple points that are just way outliers, but we're in general showing what's happening with that data. Well, we then know once we pick 2 points, we can write the equation of a line, because that's what we did in our last unit. So if we want to write the equation of this line, we now know we can find the slope between these 2 points. So to find slope, we do 4.5 minus 3 over 13 minus 8. Well, 4.5 minus 3 is 1.5. 13 minus 8 gives me a 5. Now, we don't write something with a decimal inside a fraction, right? That's just not an option that we use. So we can either just divide this out and turn it into 0.3, which is fine. Okay, or you could turn that into a fraction if you wanted to, but we're actually talking about something that's dealing with cups of waters and miles, distances, right? We're dealing with things that we represent in decimal format. So if it's something that we represent in decimal format, it makes sense when we talk about it, we would talk about it in decimal format. Now, all this 0.3 gives us is our slope. We know if we actually want to get the equation of the line, we then need to pick one of our points and our slope and plug this into point slope format. And we also know that this isn't the form that we leave our answer in, and so we will distribute and solve. Oops. So 2.4. We'll undo subtracting 3 by adding 3. Plus 0.6. Now, what this is telling us is that if we were to represent this data in one mathematical equation, a general idea of how we could represent all of these points, this is the equation that we would use. Now, this equation in the future is going to give us more information, but for right now, let's just focus on sort of getting those sort of points and what that general data trend looks like. Okay, so we're going to look at another one here where we sort of have to do a little bit more of the heavy lifting, and that scatter plot isn't just given to us. Okay, you should have already talked about making a scatter plot, but just to make sure, let's fill in some of these pieces here. So the following data set show the number of days a student is absent in a trimester and the average score they get on their exams. So it's saying this student missed 0 days and got an 88 average on their exams. Okay, this student missed 14 days and got a 50 average on their final exam. We want to turn this information into a scatter plot. So to do that, right, our x-axis is always our first, so this is going to be our days absent. Now, this isn't labeled for us, so we need to get this labeled, which means we need to consider what is the best scale that we could use. I don't want to count this as 1, 5, and 10, because then all my data is in this little teeny tiny squished area. Okay, but I also don't want to go every 5 and then count 1, because it then won't fit. So we really need to think through what is the best way that we could get this data on here. So if I count this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 26, 27, 28, 29, 30, 31, 32. Okay, so I have 32 spaces. If I need to get to 17, if I count every 2, then I'm not going to have enough space, right? Because it'll be 34 and I only have 34 squares. So each dash is going to have to be 1 day. Now, I think if I start labeling 1, 2, 3, my numbers are going to start to get really squished. It'll be hard to tell. So I'm not going to actually put a number on the 1, but I'm going to put a number on the 2. And I'm going to count by 2s. Now, could you decide to number every one? Yes. Okay, but I think for me and my handwriting, that's going to get a little bit too squished together, and that's going to be hard for me to tell. And so if I just write every other line, it's still going to be pretty clear to me where each day is. Again, your objective is to just create it so that we're giving clear information, right? It's easy to tell what's going on. Okay, on our y-axis, we're going to have our exam score. Now, the tempting thing to do here is to say, oh, well, I only need the smallest number of 32, so can I just put 32 down here? We really want to try and avoid that because that's actually our origin, and our origin always starts at 0, 0. So we really do want to have 0 here and be starting at our origin. So then as we're going up, I need to fit from 0 all the way up to 95. So I'm probably going to have to count like by 5s or something. So if I go 5, 10, 15, 20, 25, 30, 35, 40. Yeah, so I'm just counting to make sure that will fit if I count by 5s. Now again, same thing. If I put 5, 10, 15, I think that's going to get a little squished. So I'm going to go 5, but then write the 10. 15, 20, 30, 40, 50. Now, could you decide to do something like count by 6s? I mean, the answer is yes, but counting by 6s isn't something that naturally sort of comes to us. And then we're sort of going, okay, well, how far is that in between, right? Our objective is to make this as readable and as easy to sort of find that info as possible. Okay, so now we're gonna go through and we're gonna start plotting the data points. So I have 0, 88. So right now this is a little bit of tedious, so I'm just gonna go through and start plotting these points so you can sort of follow along, but I don't have a lot to add other than 0, 88 is up here close to 90. Now, do I have to approximate? Yes, a little bit. Okay, 5, 70. And I'm just plotting each of these points. A little bit hard to do with the camera in between here, but we'll get it done. Okay, so once we have all these points on here, right, the same idea, we want to see if we can't find 2 points that do a good job of representing the general trend. Okay, so what is the general trend, right? This data in general is sort of going downhill in this space. So can I find 2 points that do a good job of representing that, right? I don't want to pick like this point and this point because then that's way too steep down. Okay, but maybe if I pick sort of over here towards the end, and right, you can even sort of take a piece of paper and see where do you get some of them above and some of them below, right? Maybe here and here, I sort of see a good trend of that data, right? Some above, some below. I think that might be the 2 that I go with. Now, someone might pick something slightly different, and that's okay. That's why I said we're sort of eyeballing it. This isn't perfect. We're going to talk about ways to get this a little bit better as we continue through this unit. So if I pick those 2 points, here's my line. Now again, if I'm sort of checking those points out. So I know this one that's way out over here is my 17, 32. I know this one in here, let's see, is going to be my 380. So my points that I picked are 3, 80. And 17, 32. And again, if we're going to write the equation of a best fit line, the first thing that we need to do is find the slope. So I'm going to do that. So 32 minus 80 over 17 minus 3. So let's see. It's a negative 48 over 14. And I can then simplify that. Now, we're talking about days missed. I don't know that this is necessarily talked about as fractions of a day or something like that. We get a messy decimal. So we can either leave that as -3 3/7, which would be -24/7 if we reduce this, or we can talk about this in its rounded decimal format. And normally I would say, oh, don't round. But again, if we're talking about fractions of a day that we're missing, at a certain point, it gets a little bit unreasonable as to how many seconds you're missing in a day, right? We wouldn't necessarily do that. So 24/7 as a decimal, right? I'm just putting that in my calculator, gives me -3.42857, blah, blah, blah. So if we just talk about this as -3.4, that's going to be fine. Okay, so if we plug this into point slope form, here's my slope, and I'm going to pick a point. But I don't want to leave it in this format. I'm going to solve it for y. So I'm going to distribute. 2 negatives make a positive. Okay, so we'll get 10.2. It makes sense that my slope is negative because my line does go downhill. And so my equation is y equals, oh, I am off the screen down there. I'm so sorry. So if you missed that there, that info is. Okay, but if we go downhill there, we get our final equation of y equals -3.4x plus 90.2. Now, I do want to talk about one added piece with making these graphs. And that is just, what do we do when these numbers get ridiculous? There's no way in this situation, okay, that's talking about the population of Westfield, do I want to number my x-axis from 0 all the way up to 2020? And there's no way I want to label my y-axis from 0 all the way up to 45,800. That's just not realistic. So how else can we talk about tables that get big, complex numbers without having to worry about labeling and making a graph that's ginormous? Okay, and there's a couple things that we can consider to help bring those numbers down. One of the things that we can consider is not talking about the years as their actual year number. Instead, talk about the year as when we first start collecting the data. So if the first year that we have data is 2010, let's just say that that's our starting point, and that's year 0. And so then after that is 1 year away from that, 2 year away from that, right? And we can do these numbers.